Okay, remember on these problems where they give us like g prime equals the integral of f? Remember when you do the derivative of the integral, you get the inside function. So g prime is going to be equal to f, g double prime is equal to f prime. This is the graph of f, which is also the same thing as g prime right there. So just kind of keep that in mind. G of 3 means you got to take that 3, plug it in for that x right there. So you see all my work for this problem right here. When you do g of 3, you plug that 3 for the x, and then so you're going to do the area. Remember, your integral is area between -3 and a +3. So then that means when you look at your graph and look at the area, you're going to do this triangle right here. So the base is 5. So you're going to go 1/2 times the base, which is 5, times the height, which is 4. So that'll be that area right there. And then what you need to do is subtract out. You're going all the way up to this +3, which is right here. Now, what I did just to be certain is just, I found the equation of this line real quick over here, and then I took 3 and plugged it in. I did get that was -2. Usually when it looks like it's on a nice number, you could say that's on a nice number, but if you're ever not sure, like one time the answer was like 5/8 instead of 1/2 or something like that. So just be a little bit careful with that. Most of the time you'll be safe. But then I got that -2. So then I did 1/2 times the base, which is 1, times the height, which is 2. But since this portion of the graph went below the x-axis, I had to subtract out that area. So I did the positive area for that top rectangle, that top triangle, and then I subtracted out that little triangle. So I got 10 minus 1 to get a 9 right there. And then no calculator on this problem, but they keep those numbers pretty easy to work with there. And I really want to spend a few seconds talking about letter B, because they seem to like these kind of problems the last several years worth of testing there. So it's asking us to do a couple things. It wants to know, where is G increasing and concave down, increasing and concave down. So I'm just trying to talk myself into getting the answer here, okay? So I said G is we know G is increasing if the G prime is positive, right? And then since G prime is equal to F, if I want to know where G prime is positive, that's the same thing as me asking myself, where is F positive? And this is the graph of F. So if I want to know where that graph is positive, it's where that graph has positive Y values. It's where that graph is above the x-axis. So since I had to do more than one thing here, I just kind of jotted that down for myself. I boxed that, and I'm going to look at that second item. And instead of trying to do two different things and then do the intersection, I'm just going to just stop right there for a second. The other thing we were supposed to figure out, where is G concave down? So I know G is concave down where the second derivative of G is negative. And since G double prime is equivalent to F prime, that's the same thing as me asking myself, where is F prime negative? And then I'm not given the F prime graph. If I was given the F prime graph and I want to know where the F prime graph was negative, I would look at where that F prime graph is below the x-axis. But I don't have the F prime graph, I have the F graph. So to get from the given F graph to the F prime, that's the slope of that F graph. So if I want to know where the derivative of F is negative, that's the same thing as saying where is the slope of F negative, because if the derivative is negative, that means the slopes of that function are negative. So slopes of this function are negative. You know, by looking at a graph where the slope is negative, you're looking at where that graph is going downhill. And so that's where that F is decreasing or going downhill. And so this particular problem, we got to pick out the intervals where both things are true, where we're both above the x-axis and going downhill. So above the x-axis going downhill right there, and then also right there. So that's why we're talking in between that -5 and -3 and the 0 and 2. So just try to organize that in your brain, make sure it works in your head there, because you'll do some other things like that. The last several years, they tend to like things like that because you're doing more than one thing, but you're still making those connections with your first derivative, your second derivative, above and below, increasing, decreasing, things like that. And then letter C and D, I think we'll kind of like these things. These will give us a gauge too for what kinds of things are thrown at us without the use of that calculator, right? All this stuff we can handle without there. Now, before I forget, if the numbers ever do get kind of large and you're not sure what it simplifies to, you could have left your answers like -75 over 225. You're going to get full credit for that. But if you see it simplifies easier, you go ahead and do that. Here you have a quotient, and you're supposed to do a derivative, so just do your quotient rule. So I did a denominator times the derivative of the numerator minus the numerator times the derivative of the denominator, all over the denominator squared, and then I'm just plugging stuff in. G prime of 3, so I'm plugging in a 3 for all of those. Now, when I had to do G of 3 was the answer you found in part A, so that was 9. okay? And then the g prime of 3, I had to do something different for that. So we set up here, if g was the integral of f, g prime is equal to f, which means g prime of 3 is equivalent to f of 3, and f of 3 is what we found up here. That's on my f graph when x equals 3. What's that y value? So that's where we're getting that -2 right there. And then it's just some arithmetic the rest of the way. And in letter D, it says find the slope of the tangent line. You know slope is derivative. It doesn't say find the equation of the tangent line. For you to do the point slope form, it says find the slope of the tangent line, which means what's the derivative of that p at x equals 1. So this is like f of this. This is like your chain rule composition function right there. If this is our original function, you're going to do the derivative of the outside function, leave the inside function alone, and then times it by the derivative of the inside function. That's your chain rule. And then now you're going to take that -1, plug that in for the x's, do some arithmetic. This is f prime of 2 times -3. F prime of 2, that's the slope of your f graph at x equals 2. So that -3 carries down, and the slope at x equals 2. X equals 2 is right here, and we already kind of found the slope of that line. That was -2. So you're just going to go -2 times 3, get that +6 right there. Scuba Steve.